countries in the world that don't use the metric system: Liberia, Burma, also called Myanmar, very backward country by the way, and the United States of America. Those are the only 3 countries in the world that don't use the metric system 100%. It's a long and complicated story as to why it's working like that, but this girl here sings this great song.
So, that was a kind of stressful time, and I want to do a song right now about a time that was also really stressful in United States history. It didn't happen that long ago, and it was in the 70s, and it was when the people of the United States and the government of the United States were at complete odds. And it was touch and go there for a while. Have your parents told you about that in the 70s? You guys, that terrible time in the 1970s? No? Have they shown you pictures of them in the 1970s? And a duster and, no? Okay, maybe they're just guarding you because it was a really traumatic time and maybe they'll tell you about it in a couple of years. So I hate to spoil your natural child rearing in that I'm going to tell them about it now. Okay? So anyway, this is about the terrible time in the 1970s, and I apologize if it's a downer and it brings any of you flashbacks. Back in '99, there was that fear of Y2K. We'd wake up at the Stone Age at the dawn of New Year's Day. Some talking heads from CNN proclaimed we ought to stash a year of bottled water, batteries, and extra cash. Turns out nothing happened, things were fine with even so. Some of us had flashbacks to 30 years ago. A cataclysmic cloud that foretold awful things in store. Life as we know it was gonna be no more. See, Congress had decided that they all were really weary of sharing weights and measures with just Burma and Liberia. And so they passed a law to freaking check me out alive. The metric conversion of 75. Metric is coming. Metric is coming. Ah! Oh. We went through the streets, wailing and running. Metric is coming. Metric is coming. They were coming for our cups, our quarts, our ounces, and our grams. Fahrenheit to Celsius, pounds to kilograms. Maggots would not feel the yardstick cracking or their head. They get concussions with meter sticks instead. Then came the cry of protest from the local corner bars. They cannot take our case. They will not take our yards. We'll fight to keep each fight. We'll fight down to each ounce, cause 47 pounds the liter is just way hard to pronounce. Metric is coming. Metric is coming. Ah! Oh. We went through the streets, wailing and running. Metric is coming. Metric is coming. And came the day of reckoning. The country woke distraught. We turned on the TV to see what havoc had been wrought. The weatherman predicted sun from Maryland to Maine, but warned the West Coast might see up to half an inch of rain. Inches, that's not metric. They haven't switched it yet. Hey, maybe if we don't say anything, maybe they'll just forget. 30 years have come and gone, avoiding service well. The first no public policy of don't ask, don't tell. Metric is coming. Metric is coming. We went through the streets, wailing and running. Metric is coming. Metric is coming. They said the English system was outdated and confusing. Too hard to convert, too many units to be using. What a load of garbage. We've been coping all along. Tonight we're gonna prove those metric pushers they were wrong. Here's the sing-along part. I'll say the unit first, then you sing the new equivalent after you've done the conversion. No need for calculators. This thing will be a breeze. When you get the answer, say it nice and loudly, please. The old faithful system is easy and good. We all know 12 inches equals. And 2 more than that, you know it's not hard. We all know that there are 3 feet in a moving to miles we can't be beat. It's 5,280. And while we're on miles, we clearly can state the number of furlongs in 1 mile is. As weighing stuff goes, we won't be undone. We know that there's 2,000 pounds in a ton. Let's switch to fathoms, it's easy to do. When fathom and inches is. Thank you, Popeye. Yeah, we need to bring on our liquid won't come up short. 32 fluid ounces are enough. We haven't stopped yet. We can do more. The number of quarts in 1 gallon is. They say it's unwieldy. We'll say they're absurd. In tablespoons, 1 teaspoon equals. Teaspoons and gallons will not hesitate. We all know there's 120. Fine, sir. 768. Second guess, right? We're on a roll. We're out for the kill. We all know 4 ounces equals 64 cups and 1 gram, that's for sure. In teaspoons, that's a lot. Thank you. Reverse. 36,864. Last math test? You should know that. Oh, it's okay. It's holiday vacation. You're okay. Okay. Clearly, we've converted. We've shown that here tonight. Hey, we don't need the metric system. Ours is all right. Let the world have their base 10 system, and we'll keep ours. Who cares about a satellite or two? We've lost our Mars. And in the early 80s, Congress knew that they'd been beat. The metric system folded. It went down in defeat. Meters, liters, kilograms we'll put out on the bench, cause we won't use a system designed by the French. Metric is coming, metric is coming. Oh, we went through the streets, wailing and running. Metric is coming, metric is coming.
Okay, there you have it. Did everybody get all of those right? No. Okay, well, I wrote a few of them down here. I think one of the things that's always important to know about the English system is most of it came from the king, okay? And the king would take a piece of paper here and stretch it out like that, and that was a yard. That's the way they measured cloth. 1 yard, 2 yards, 3 yards. This fathom thing, interesting story. A fathom is 72 inches. That's supposed to be from the king's tip of his finger here to the tip, 6 feet.
That's a lot.
But, you know, you get a new king, you've got a new fathom, right? So the metric, in the English system, if you want to know what the real standard is, you have to go to this place that's just north of Washington, D.C., in Rockville, Maryland. It's called the Bureau of Weights and Standards. And they have a bar of metal that's kept under climate control and temperature and so forth, and it is exactly 1 foot long. That's the only way, if you really want to know what a foot is, you have to go there and measure against it. The same thing is true of a pound. They have a chunk of metal there that also they keep at the right temperature and at the right humidity so it doesn't rust or anything, and it's 1 pound. That's the only way to do it. I mean, because there is no way to figure it out like there is with the metric system. Make one last comment about this fathoms that I forgot. Does anybody know where Mark Twain got his name? Measuring the depth of the river. He was on steamboats going up and down the Mississippi River, and they were very flat bottomed, so they didn't need a lot of water, which was great because there's lots of places where the Mississippi's pretty narrow and there's sandbars coming out and all that stuff. But his job was to stand up on the front of the ship, and he had a rock and a rope, and he would throw it in, and if it was still floating at 16 feet, 12 feet, 2 fathoms, he would call up to the captain and say, Mark Twain, Mark II. There's 2 fathoms of water here, so we're okay. And if it got less than that, then the captain was backing away and going to find some other route up the river. His real name was Samuel Clemens, you probably remember that. Mark Twain was just his pen name, but it worked pretty well for him. Anyway, okay, so I think the biggest problem with the English system is that the conversion factors are all craziness. I mean, they really are. I mean, whoever would have come up with 5,280 feet in a mile? Really? So the metric system came along, and they decided they would, it was a group of scientists from around the world. They did meet in France, and so that's why the line in there about we're not going to take anything that came from the French, which is kind of an American attitude, I think. But they decided it would all start with a distance, okay? And so what we're gonna do is we're gonna come up with this distance. This is 1 meter, by the way. This is a meter stick. And the thing to remember about a meter stick is that it's longer than a yardstick. A yardstick, here's on the back side, would only be 36 inches long. So you'd have to take that much of it off. That's now a yardstick from there to there. Okay, so remember that meters are longer. I always figure that'll be important one day when the National Football League converts to the metric system, and now instead of being first and 10 yards, it's going to be first and 10 meters. Oh my God, it's going to be 3 inches longer each yard. Okay, but that'll probably never happen. Anyway, so how did they come up with this distance? Anybody know? This is 1/10,000,000th of the distance between the equator and the North Pole. 1/10,000,000th. Now you think, well, how did they figure that out? Well, it was not easy, I guess. They came up with another way to determine it, and that was they made a pendulum. And you know, pendulums, the only thing about the speed of pendulum moves back and forth is the length of the arm. And so the length of an arm of a pendulum, this will do 1 second per back and forth, is also 1 meter. Anyway, there is an official meter. It sits in a laboratory in Paris, France, and that's the international standard meter. But this is pretty close, okay? Now, the other thing to think about with the metric system is what other things do we need to measure besides length? Volume. What's volume? What does that mean? What does volume mean? Amount of space taken up by matter. That's right. So name something that we measure. What's a unit of volume in the English system? A gallon. Yeah. You go to the gas station, you buy a gallon of gas. And you know how big a gallon is because you've got milk jugs in your refrigerator that hold a gallon, right? And if you went to the gas station in Canada and you said, give me 2 gallons of gas, they'd look at you like you were some kind of a nut because they sell gas up there in liters. Okay, so the question I might ask, and you need to understand, is how do you get from a distance like this to a volume of space? How do you do that?
You multiply distances by each other, so like height, length.
Oh, like height by width by length, that sort of thing? Yeah. And so what these guys did that were making up this system was they said, I'll tell you what, let's take this meter and let's say, let's make up our unit of volume, and let's call this unit of volume, the main unit of volume, we're going to call it a liter. And so they came up with a box like this, and they laid their little ruler on there, and they said, oh, that's 10 centimeters by 10 centimeters by 10 centimeters. In other words, it's 1/10 of a meter by 1/10 of a meter by 1/10 of a meter. And that is the definition of a liter. Okay? So remember, it all starts with the stick. And from the stick, we can go to volume really easy just by measuring a box. Okay? This is a 1 liter box. Okay? So if you bought gas in Canada, this is what you would get. They would fill this up with gas for you. And they would charge you about a quarter as much as they would for a gallon of gas. So if gas is $4 here, it would be $1 up there on the gas pump. Now they're not exactly the same because you see that a liter is a little bit more than a quart. So therefore a gallon is a little bit less than 4 of these. but it's pretty darn close. Okay. Now, what's another thing we need to measure besides length and volume? Mass. Mass, what does that mean? Weight. Yeah, mass is the same as weight as long as you stick to one rule, and that is you measure it here on Earth. Okay? If you go to the moon, where gravity is very different than it is here, then mass stays the same, but weight changes. Okay? So just so you know, here on Earth they are the same, but I always had a hard time conceptualizing that myself when I was trying to first learn this. Okay, so how are we going to take a stick and come up with a unit of weight?
They measure like the weight of a liter of water and just turn that into a...
Hey! Wow, smart guy up here. Are you the smartest guy in the class?
I mean, I'm only one of 3 guys, so...
He's the smartest guy in the class. By a few for that.
I have to tell you a story about myself if I can borrow a piece of your desk here. My mom and dad told this story on me my whole life. I started first grade when I was 5 because they sent me to some testing and they said, oh yeah, he can start first grade. So I did. It was the worst mistake I ever made because I was always the youngest, most immature kid in my class. And you know, there's so much more to school. There's so much more to school. You the youngest kid. My mother, good for you. Socially, it makes it difficult. Let's just put it that way. I didn't get to drive till I was a senior. Come on. Anyway, so that's exactly what they did. And they said, well, let's take this box here, this 1 liter box, and let's fill it up with something that we can reproduce all over the world. We won't need any special stuff to put in it. We'll just use something that's ubiquitous, it's everywhere. Let's use water. Yes. And so they did. And they decided they would take a liter box, which is what this is. Now it's not perfect because it's plastic and it's not highly scientific, but anyway. And so here's our liter box, and you see it's 10 by 10 by 10, right? And we're going to put it on this scale here, and we're going to zero it out. Water. Now, to be really fancy, you need water at 4 degrees centigrade. In other words, just above freezing. Why would you want water at 4 degrees centigrade?
It's most dense.
It's the most dense, that's right. Water gets denser and denser and denser until it freezes. Once it freezes and gets to 0, then it floats, right? You guys have had ice cubes on a drink before? Yeah. Okay, so let's just see how well this works. Let's just take, this is not pure water, and it's obviously not at 4 degrees, but it's pretty close. And I think actually we don't go to the very top, because there's a line right here. Tell me when I'm getting close.
It's ruined flats.
0.84. Well, we're not there yet, so we're going to just keep going. 0.89. I think our scale isn't very accurate. That's not even 0.89. Well, it doesn't matter when you're wearing cats that much, I guess, huh? I think that's a cat scale. Well, anyway, normally the ooh-ah moment of this is when I fill that up to the top and it reads exactly 1.0 what? Kilogram. Now, what does kilogram mean?
1,000 grams.
1,000 grams. So, even though this is 1 meter, right, and you take 10 centimeters, or 1/10 of it, to make a liter, to make a gram, which is the basic unit of measuring weight, what you want is you want to take a little box, which is 1 centimeter by 1 centimeter by 1 centimeter, and fill that up with water, and that is 1 gram. Okay, now I was doing it with 1,000 grams because that's a better a visual maybe. All right, now, so we call that a gram. We might, in volume, what would we call that? That little blue box I just showed you?
Cubic centimeters?
Huh? We call that a milliliter, yeah. It's kind of weird though, because we have another name for it.
Cubic centimeter.
A cubic centimeter. Now, cubic centimeter just means it's a centimeter by a centimeter by a centimeter. So a cc, you'll use that term a lot, a cc is the same as a milliliter. And if the milliliter was full of water, it would weigh 1 gram. Okay? Now, the nice thing about all of this is that it's easily convertible. And I have a little handout here for you. Maybe y'all can pass these around.
Passing
I
the smaller
got 2 of these I got to get out of here. Okay. Would you pass one to everybody on that side, and would you pass one to everyone on that side? Because what I want to talk about here for just a minute is, and on the front, you can see that I listed volume, I listed weight, and I mentioned and length. And so in the metric system, there is only one measurement of each of those things. Okay? For length, the only unit is the meter. Boom. The only unit of weight is the gram. And the only unit of volume is the liter. Is that all for him? Anyway, so, but in the English system, obviously there's dozens of them. You know, for length, there's all of these different things. And for weight, there's tons, and there's pounds, and there's ounces, and all this other stuff. Which then you have to memorize the conversion factor for every single one of them in order to convert it to any single other one. We lost 2 satellites on Mars. We sent them to Mars. They were in orbit around Mars, and they were supposed to go down and land softly on Mars, and they crashed. And then they were trying to figure out, well, why did they crash? Well, it's because one group of scientists was measuring the height it was off of Mars in metric, and the other group was measuring it in feet and yards. And because of that, they didn't calculate the slowing down well enough, and you know, a few $1 billion sitting in a pile of mess on the surface of Mars. Could that really have happened? I question it myself. All right, now, so let's talk about those 3 units, those 3 units of measurement: meters, grams, and liters. And, you know, I mean, a cc or a milliliter is really kind of neat, right? But you'd hate to buy gas and have to measure out, you know, a few jillion of these things, and you'd probably need even smaller measurements to do other things. And so if you look on the back of that paper that I gave you, you notice that it says at the top, it says nano. What's a nano? It's a nanometer, a nanogram, or a nanoliter. What does nano mean?
10 to the negative 9.
And yeah, that's right. It's 10 to the negative 9th, but in dumb surgeons talk, that means it's a billionth, right? So a nanometer is a billionth of a meter. That's where Apple got its name for those little nano things, billionth. They're pretty small, but they're not a billionth the size of them. Anyway. All right, so then the next one is micro. And just for example, a micrometer is is a millionth. Micro is the millionth. That's a number that you might use if you were measuring the thickness of cells under a microscope. The width of a cell might be several micrometers. So you will use that term a lot when you're looking at things under the microscope. But once again, you don't have to say, well, geez, it's 0.0 furlongs to the -9th either. You know, you got a unit that you can kind of halfway understand. And when you say micrometer, most everybody knows what you're talking about. Okay? Like they should. And then you notice there's another one. The next one is milligram. And most of your drugs that you guys measure out to give to animals or give to yourselves on a Friday night are measured in milligrams, okay? And you don't want to give the animals too much or yourself too much, either one. All right. And then the next one there is centa. Centa means 100th. So a centigram is 100th of a gram. Then a decigram. Decigram is 1/10 of a gram. Now think about deci, because you've really known this metric system your whole life, you just never really thought about it. How many years are there in a decade?
10.
How many pennies are there in a dime?
10.
Get it? So we've been using varieties of these words forever. We just hadn't thought about it. How many centurions are there in a battalion? 100, yeah, that's a Roman thing. Okay. And then you get to the basic unit, and then you go on to start putting them together if you want to measure big things, okay? So to measure big things, you go to deca. So like a decagram is 10 grams. And here's 10 of those little boxes put together. So if this was full of water, it would weigh 1 decagram. Okay? And then we go to hecto, which is 100. You remember hectares? Hectares are kind of like an acre. That was a number based on hundreds. Kilo is 1,000. A kilogram is 1,000 grams. And then there's the next one is mega, which is 1,000,000. Now I'm always fascinated by this company in this country called Google. Anybody ever heard of it? Where did they get their name? Huh?
The Google Plus?
Yes.
I don't know, Carl Sagan.
Yeah.
Where did they get their name?
Cosmos.
From Carl Sagan and Cosmos?
Yeah.
But what is a Google? It's a giant number. It's actually, they bastardized it a little bit. It's actually spelled G-O-O-G-O-L.
Right.
And Google is a 10 to the 100th power. So it's got 100 zeros after it. Never thought about that one, did you? So we could have a Googlegram, we could have a Google liter, and we could have a Google meter. Okay? All right. Let me go over that business once again here and just show you, because these are some of the distances that I think you really ought to understand. So if we said this is a meter, and 1/10 of a meter is a decimeter. So that would mean you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. That's a decimeter, 1/10, and then you notice the numbers go, and there's 10 of them. And so then you go to the next little line, these little numbers here. How far is it from 1 to 2 to 3 to 4? Those are centimeters, right? Because there's 100 of them from here to there, so that's a centimeter. And it's about, it's about half an inch, a little bit less than half an inch, but nonetheless, kind of think about it in those terms. All right, and then you notice the little bitty lines that are up here on the top, all the little black squigglies up there. How far apart are they? Millimeters. Yeah. I was reading about this the other day, thinking about getting ready for this little talk, and in Australia they passed a law in the legislature there and in the construction trades that every single measurement in building a building or doing anything architecturally in Australia will be measured in only one unit, and that is the millimeter. So everything they measure is measured in millimeters to prevent confusion with any conversions at all, even though conversions in the metric system are so easy, because you just got to move the decimal point, right? Thought that was kind of clever.
So they're measuring their like building height in millimeters?
Mm-hmm.
That's so Lord!
Yeah, measuring windows in millimeters.
But remember that that's the beauty of easy conversion. If you've got a 10-meter window, you can get into millimeters very quickly.
Yeah.
Yeah.
So that's the point. A couple other things that you probably, let's see, so that's going down. Let's go longer a little bit. Let's talk about a kilometer. Now, I came from Arkansas originally. We always call it kilometers, right? Kilometers or kilometers. How far is a kilometer? Well, no, I don't think in English. How far is a kilometer? 1,000 sticks, right? So you lay 1,000 of these babies out there, and that's a kilometer. And it actually works out to be about 0.62 miles. And the reason I know that is because I used to run a lot, and we would run 10K races. You see those on the paper every week. So-and-so ran a 10K in such and such a time. Well, 10K is 10 of those, and it's actually 6.2 miles. So that's about, there's only about 3 conversions that I know, I promise you. The ones I know are that a kilometer is 0.62 miles. I know that a centimeter, there's 2.54 centimeters to the inch. And for weight, I know there's 2.2 pounds to a kilogram. In humans, we try to do everything in the metric system, in the healthcare system, but let me tell you, when you ask somebody, how much do you weigh, most people don't say, well, I weigh 98.2 kilograms. They'll usually say, yeah, I weigh 220 pounds, close to that. So, we're always struggling to get us out of the English thinking, but there's so many things that it's really hard to change people's thinking on, and that's certainly one of them. But I bet everybody in the room, if you've got one of those electronic scales at home, just like this thing here, there's a little button on the bottom of it under here, and it says pounds or kilograms. So you could weigh yourself in kilograms if you chose to. Most of the dosages of the drugs that you will use will be milligrams per kilogram. So if the dog weighs 10 kilograms,